Welcome students, let me continue our next class on limits and derivatives. See, in the previous class we are discussing about the standard limits and we have discussed already this limit x tends to a x to the power n minus a to the power n divided by x minus a. This is equal to n a to the power n minus 1. This one we have already studied and the proof is also completed. And next to this we need to study another important limit, that too standard limit, trigonometric limit here. See what's that statement here. Let me take into consideration this one as b, that we have studied as a. Limit theta tends to 0, limit theta tends to 0, sin theta upon theta. This is the standard pattern, you remember here, sin theta upon theta. This must be equal to what here? 1 here. So this is what the limit, where theta is measured in radians, where theta is in radians. This is in radians. So this is what the property, a standard limit here. Now let me discuss step by step. Some considerations are needed here. You need to consider a circle here. Here is a circle. There is a circle with center O, and then O is the center of the circle here. O is the center, circle with the center O, and on the circle I would like to mark 2 points A and B. See, this is the point, say A, this is the point B. I have marked A and B such that mark A and B such that angle AOB equal to theta. Angle AOB equal to what here? Theta radians. This angle is equal to. So this angle is theta radians. This is what O here, the center here. Then here, this is the center. This is the center of the circle. I have marked 2 points A and B such that angle AOB equal to theta radians here. And further, at a point A, you need to draw a tangent here, and then it needs to join OA, OB and AB here. Join OA, OB and then AB, and further draw a tangent. Draw a tangent. Where we have drawn the tangent? See, I have drawn the tangent at the point A to this circle here, at A, and then further produce OB to meet the tangent at C. Produce OB to meet the tangent at C. Take it as C here. Okay, take this point as C here. And then further, lastly, I would like to draw BN which is perpendicular to OA. Draw BN perpendicular to OA. This is what a preliminary consideration what we need to take in order to prove limit theta tends to 0 sin theta upon theta. Okay. See, once again I would like to brief this one. There is a circle with center O. A and B are marked such that angle AOB equal to theta radians, and then at A I have drawn a tangent and OB meets the tangent at C, and we have joined OA, OB and then AB here. So this is what the preliminary consideration here. Okay. So with this calculation, with this data, what we need to calculate here. See, this is the center, this is A, this is B, this is C, and then this is N, and then this is theta radians. Please concentrate. Some areas we need to calculate here. In the first part of the calculation, area of triangle OAB we take. Next part, area of the sector OAB you take here. Next to that, area of the triangle OAC will take here. Now let me calculate one by one. Area of triangle OAB. Please respond to my question here. Area of triangle OAB equal to, what can you say? 1 by 2 basic formula for the triangle, base and height. What you are going to write? Area of triangle OAB equal to 1 upon 2, what to write? Come on. Hello? Not possible to respond. Once again repeat.
OA into BN.
OA into BN. Okay, it's correct. OA into BN. OA is the base. BN is the height here. See, I want to convert BN in terms of OA and OB. OA or OB here. That is what my motto here. So BN is the side which is opposite to this theta here. And then in triangle OBN, it is better to take OB. BN upon OB ratio I want. That's why I would like to define sin theta. See, in triangle OBN, if you define sine of angle theta if you define, opposite side is BN, hypotenuse is OB. So what you are getting, BN is equal to OB into sine theta. BN is equal to OB sine theta. Make use of that value here. If you use that, area of triangle OAB equal to 1 by 2. OA is R. BN is OB sine theta. Okay, OB into sine theta. Now once again you substitute the value of OB, which is also R, and then sine theta. So altogether what we will get here, 1 by 2 R square into sine theta. Okay, this is what area of triangle OAB. Area of triangle OAB. See, one more area I would like to choose, the area of the sector OAB. I would like to sector here. This is the center. This is the center O. See, this is what the sector here. AB arc and the two radii. This area of the sector is that you have studied already in trigonometry, radii and major. First topic here. Directly you take it. Area of sector OAB equal to 1 upon 2 R square into theta. Okay, this is what the second calculation. Next to that, let me calculate the triangle OAC. Okay, area of triangle OAC I would like to calculate. So for that, what we need to do, please concentrate here. See, area of triangle OAC equal to 1 by 2. Please tell me what is the base for this triangle OAC. Which one you want to take the base? Come on. OA. Then height is?
AC.
AC is the height. Okay. I don't see AC is not the standard length. I want to convert it in something else. So for that, what you need to do? Define tan theta. Where? In triangle OAC. In triangle OAC, if you define tan of angle theta, see what happens. Opposite side divided by base here. What is opposite side? AC is the opposite side. Base is OA. Okay. So tan theta is equal to OA is AC is, you keep as it is. Not tan theta, you exchange this in this manner. Please concentrate here. AC equal to OA into tan theta. We can write OA into tan theta. So this is what you need to convert and replace that value here. So it becomes 1 by 2 OA. For the timing you write as it is, or you may substitute R here. AC is nothing but OA tan theta here. So OA is R, radius here. So 1 by 2 R into tan theta. So altogether what we will get here, 1 by 2 R square into tan theta. What is equal to? Area of triangle OAC equal to here. See, three areas we have calculated. Area of triangle OAC. Please concentrate here. I have calculated the area of triangle OAB, sector OAB and triangle OAC here. Three areas we have calculated. Out of all this, OAB triangle is smaller, and then OAB sector is little bit bigger, and then OAC is still more bigger here. So that's why here in the form of inequality, how can we write here? Area of, please concentrate, area of triangle OAB, which is definitely less than area of sector OAB which is definitely less than area of triangle OAC. Area of triangle OAC. Okay, this is what the inequality. So its formula we have proved already, 1 by 2 r square into sin theta. You check once again, please concentrate here, I will go back. 1 by 2 r square sin theta, next is 1 by 2 r square theta, next is 1 by 2 r square tan theta. Let us use that. 1 by 2 r square theta this is, and then this is 1 by 2 r square into tan theta, sorry, this is tan theta, 1 by 2 r square into tan theta. See it, let us divide by 1 by 2 r square. If you divide by 1 by 2 r square, which is a positive value, no change of inequality, 1 by 2 r square will cancel, sin theta remains, which is less than 1 by 2 r square cancels, theta remains, which is less than tan theta. Now I would like to divide by sin theta. Divide by sin theta. If you divide by sin theta, see what happens. This is sin theta upon sin theta, and then this is less than theta upon sin theta here, and then tan theta can be written as sin theta upon cos theta. This is to be divided by what here? Sin theta. That I would like to write conveniently as 1 upon sin theta. See, I have divided by sin theta. See what happens. This sin theta cancels. Sin theta cancels. 1 remains, which is less than theta upon sin theta, and then which is less than 1 upon cos theta here. Now you take the reciprocal. 1 upon 1. Taking reciprocal. Vetkrama. Okay. If you take the reciprocal, 1 by 1 is 1 only. But theta upon sin theta becomes sin theta upon theta here. Okay. And then 1 upon cos theta becomes what here? Only cos theta here. Please concentrate here. One interesting thing here. If you take 2 and 4, 2 is greater than 4 definitely. If you take the reciprocal, it becomes 1 by 2, which is not greater than 1 by 4. It is definitely less. 1 by 2 is less than 1 by, sorry, extremely sorry. See, please concentrate here. 2 is less than 4. 2 is less than 4. If you take the reciprocal, what happens? 1 upon 2, and this is 1 upon 4. In this case, definitely 1 by 2 is greater. 1 by 2 is greater here. 1 by 2 is greater here. So when you take the reciprocal, the inequality reverses. So less than is there, you need to reverse it. Greater than, again this is greater than here. Now observe here, we need to find the limit theta tends to 0, sin theta upon theta. So that's why you apply limit theta tends to 0 at this step. Limit theta tends to 0, just a minute. Now at this stage, applying limit theta tends to 0, limit as theta tends to 0 on both the sides. I will that is for that inequality I would like to apply here. See left side, what is there? 1 is there here. Limit theta tends to 0, 1 here, and then limit theta tends to 0. This is sin theta upon theta, and then this is not equal to, sorry, limit theta tends to 0, which is greater here. You write greater. Limit theta tends to 0, sin theta upon theta, which is greater than limit theta tends to 0, and then cos theta you need to write. So let us evaluate separately here. This is limit theta tends to 0, 1, which is constant. 1 is a constant, so 1 only it is. This is limit theta tends to 0, sin theta upon theta, you keep it as it is. This is what we need to calculate here actually. And then theta tends to 0, that you substitute, this becomes cos 0. Okay, this is cos 0. So 1 is less than limit theta tends to 0, sin theta upon theta, which is greater than 1. What does it mean? Limit theta tends to 0, sin theta upon theta is less than 1 here. This is less than 1 and this is greater than 1. See, sin theta upon theta, limit theta tends to 0, sin theta upon theta is slightly less than 1, slightly greater than 1. In the language of limits, how can we write this? Limit theta tends to 0, sin theta upon theta is definitely equal to what here? 1. So this is what the proof of the standard limit here. When theta approaches to 0, the value of sin theta upon theta is approaching to 1 here. That itself is written in the language of limits as limit theta tends to 0 sin theta upon theta equal to 1. And better you remember this is also possible. Also it needs to remember limit theta tends to 0, theta upon sin theta if you take, this is also leading to 1 here. So this can also be taken as a standard limit. Okay, anyhow I have completed the proof of this theorem. If you have any difficulty, please tell me. Okay, students, let us continue some problems here. I have completed the theory part almost. And then first of all, I would like to take some solved examples from our text here. Almost I will cover all the textual questions. NCERT I would like to complete. I would like to cover completely here all the solved examples as well as the exercise. Okay. So first of all, let me take the first one. See, question is to evaluate this limit. Means to find the value of the limit here. See first one. Limit x tends to 1. X tends to 1. X cube minus x square plus 1 is there here. See, here this can be evaluated by direct substitution method. If you put directly x equal to 1, you see what happens. 1 to the power 3 minus 1 to the power 2 and then plus 1. It is not at all taking any 0 by 0 form. So directly you can evaluate it. So 1 minus 1 plus 1 plus 1 minus 1 cancels. Answer is 1 here. Let us take the next example, second one. Please concentrate here. Limit x tends to 3 and then write simultaneously x into bracket x plus 1. Wherever x is there, there you substitute x equal to 3 here. So this is equal to limit x tends to 3, no need to write because I would like to evaluate directly. So take 3 here, 3 into bracket 3 plus 1. So 3 as it is, 3 into 4, 4 into 3, value is 12. I hope you followed the solution. Both can be directly evaluated here. So next one you see x tends to minus 1 is there here. 1 x squares 1 up to x to the power 10 is there. See, x to the power 1, nothing means it is 1 here. 1 to 10. See, 1 we can write. Further, plus of minus 1. Plus of minus 1 to the power 2. Next, in the sequence, what we will get here? Minus 1 to the power 3 and then plus so on, plus minus 1 to the power 10 here. So what we can write? 1 we can write here. Next, first term is minus 1. Here minus 1 square, it becomes plus 1 here. So next one is minus 1 plus so on dash dash, what we can write here? Lastly plus 1 only you can write here, because minus 1 to the power to the even power, this is always plus here. So lastly plus will get here. So apart from the first term, you see here one is negative, another one is positive. First term on the better, 1 is the first. Next x to the power 1, then the think part 1, 3 and then 5, 7, 9. These are odd, all give minus. So that minus will cancel with next term subsequently. So what remains? Equal to 1 remains here. Otherwise, you write all the terms, intermediate terms you write and then you calculate in that manner also you can do. But that is not necessary. Directly also you can evaluate like this here. Now limit x tends to 1. X square plus 1 divided by x plus 100 is there here. Let us substitute the value of x, which is equal to 1. Again, this can be directly evaluated. So x equal to 1, if you substitute 1 square, it is plus 1 divided by 1 plus 100. So this is leading to 1 square is 1 only, 1 plus 1 is 2, 2 divided by 101. 2 divided by 101 is the answer here. So let us take into consideration the next question. Question is to evaluate this limit here. If you take into consideration the direct substitution, see 2 to the power 3, which is 8, minus of 2 to the power 2, 4, 4 into 4, 16, plus 4 into 4, which is 4 into 2, which is 8, sorry 8. 8 and 8, the sum of 8 and 8 is 16. minus 16, numerator is 0, and 2 square is 4, 4 minus 4. So definitely it is taking what here? 0 by 0 form. It is an indeterminate form. So we cannot directly evaluate here. So direct substitution that x equal to 2 is not possible in this case. So let us try for another method. So better let me take into consideration x common from the numerator. If you take x common, it becomes x square minus 4x plus 4 here. Whole divided by x square minus 4 is there, that can be written as 2 to the power 2. Okay. If you observe the numerator, limit x tends to 2, you write as it is. Can you visualize anybody? What about the value of x square minus 4x plus 4? It can be expressed as a perfect square. It is in the form a square minus 2ab plus b square. Can you tell me how do you write it? X minus 2 to the power, hello, 2 divided by x square minus 2 square here. Now you factorize this. This is equal to limit x tends to 2, limit x tends to 2, x you write as it is, and then here only one step you change here. This one you can write it as x plus 2 into x minus 2, and at this stage what happens? One of the x minus 2 cancels, x into bracket x minus 2 only, one of the x minus 2 cancels here. Then further what? X plus 2 is there in the denominator. Write x plus 2 here. I have written x plus 2. Now if you put x is equal to 2, it is not going to take 0 by 0 form. Direct evaluation possible at this step here. So 2 into bracket 2 minus 2 divided by 2 plus 2 here. X equal to 2 you need to substitute here. So 2 into 0 divided by 2 plus 2 is 4 here. So this is 0 by 4. Answer is 0. It is valid. 0 upon 4 is valid here. Don't confuse again. Further, it is not indeterminate here. 0 upon 4 is a valid answer. It is finite. 0 is a finite value here. Now let me take the next example, third sub question here. Another similar example is there. Very, very similar. Limit x tends to 2. Write as it is. X square minus 4 can be written as x square minus 2 square here. Take x common here. X common. If you take x common, it is x square minus 4x and then plus 4 here. Exactly similar. Simply numerator and denominator are exchanging. This is limit x tends to 2. Limit x tends to 2. X minus 2 into x plus 2, here it is numerator, divided by what is that here? X into bracket x minus 2 to the power 2 here. So one of the term x minus 2 from the numerator gets cancelled here. X tends to 2. X plus 2 remains in the numerator divided by x minus 2. Here x minus 2 square is there, one of the term cancels here. X plus 2 divided by x into bracket x minus 2. Okay. One term of x minus 2 from denominator will cancel with the numerator term. And then you substitute now at this stage. 2 plus 2, 4 divided by 2 into bracket 2 minus 2, which is nothing but 4 divided by 2 into 0 is 0. See, anything divided by 0 is not possible. It is meaningless here. Which is not possible. Which is not possible. ಇದನ್ನ ಇಷ್ಟೇ ಹೇಳಬೇಕು, ಬೇರೆ ಯಾವುದೋ ಮೇನ್ಲಿ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಹೋಗ್ತಕ್ಕಂಥ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. Now let us take the next example. Limit x tends to 2. Limit x tends to 2. X cube minus 2x square divided by x square minus 5x plus 6 is there here. This is the given problem. See, what you can take common from the numerator, x square can be taken outside. Limit x tends to 2. Limit x tends to 2 here. Take x square common. By taking x square common, x remains here, minus 2 remains. In the denominator, what happens? X square minus 5x plus 6. Let me separately factorize this. X square minus 5x plus 6 can be written as x square minus 3x minus 2x plus 6 here. If you take x common from the first two terms, x into bracket x minus 3 minus 2 into bracket x minus 3 will get here. So x minus 3 is common. If we take x minus 3 common, remains what here? X minus 2. So x minus 3 into x minus 2 you can write. So now x minus 2 cancels. What remains? Limit x tends to 2 limit x tends to 2, you write as it is. X square divided by x minus 3. Now it is the time to substitute the value x equal to 2. After substituting x equal to 2, no need to write the limit symbol here. So this is 2 to the power 2. 2 to the power 2, x equal to 2, you substitute here. X minus 3, that is what? 2 minus 3 here. So this is 4 divided by minus 1. So the answer is minus 4. Is it clear for all? ಏನಾದರೂ ಮಿಸ್ಟೇಕ್ ಇದ್ರು ಹೇಳಿ. ಏನಾರ ಮಿಸ್ಟೇಕ್ ಇದ್ರು ಹೇಳಿ. ಒಮ್ಮೆ ಸಿಲ್ಲಿ ಎರರ್ಸ್ ನನ್ನ ಕಡೆನೂ ಆಗ್ತಾವ. ನಮ್ಮದು ಒಮ್ಮೆ ಸ್ಟೇಟ್ ಆಫ್ ಮೈಂಡ್ ಸರಿ ಇರಲ್ಲ, ಎರರ್ ಆಗ್ತಿರ್ತಾವ. Okay, let us move to the next question. That is what the fifth question here. See next one. Limit x tends to 1. X minus 2 divided by x square minus x minus of 1 divided by x cube minus 3x square plus 2x. Let me simplify this to a certain extent first. This is equal to limit x tends to 1. X minus 2 divided by x into bracket x minus 1. You can write minus of 1 divided by, taking x common, what remains? X square remains, minus 3x remains, x is taken common, then remains what? Plus 2 remains. Okay, close the bracket. So this is equal to limit x tends to 1, x minus 2 divided by x into bracket x minus 1 minus of 1 divided by x into bracket, how can we factorize this? X square minus 3x plus 2. This can be written as x square minus 2x minus x plus 2. Okay, minus 2x minus x, that leads to minus 3x here. So this is equal to, product is again first and last term, x into bracket x minus 2 minus 1 into bracket x minus 2. So as a result x minus 2 one factor, x minus 1 another factor here. So at this stage x minus 2 into x minus 1 you can write here. Okay, now you take the LCM. This is equal to limit x tends to 1 as it is. See the LCM. What is the LCM? Can you tell me, anybody? X is common. Next, what to write? Come on. X minus 1. Then x minus 2 also. Okay. X minus 1 is there. X minus 2 is not there. So this is multiplied with x minus 2. And then x into bracket x minus 2, x minus 1 all are there. Nothing to multiply here. 1 is to be multiplied. So x minus 2 into x minus 2, that is you write x minus 2 into x minus 2 itself at this stage, or you can multiply, expand it. ಹೀಗೆ ಮಾಡ್ತಾ ಹೋಗ್ಬಿಡ್ರಿ ನೋಡೋಣ. x minus 2 bracket square it is actually, minus 1 into 1 is 1 only. Okay, so by expanding this becomes x square minus 4x plus 4. Limit x tends to 1. X square minus 4x plus this is equal to, you see here, limit x tends to 1. Let us expand x minus 2 bracket square. X square a square minus 2ab minus 4x it is, plus 2 square is 4 only. See, a square minus 2ab plus b square, that is 2 square is 4. Next minus 1 is there, write minus 1 divided by what? X minus 2 x minus 1 x minus 2, x into bracket x minus 1 into x minus 2. See, if there is any error, please observe here. X minus 1 x minus 2. Okay, now observe what happens. 4 minus 1 is 3. This is equal to limit x tends to 1, x square minus 4x plus 3 whole divided by x into bracket x minus 1 x minus 2. Again it can be factorized, I think so. 3 and 1 separately I would like to perform here. Please concentrate here. X square minus 4x plus 3 is there. X square minus 3x minus x plus 3. Now sum is minus 4x. Product is first and last term product. You will tally x into bracket x minus 3 and then minus 1 into bracket x minus 3. So the first factor is x minus 3, second factor is x minus 1. So let us continue this. That is SLC work. You are already familiar with quadratic equations, how to factorize quadratic factor. ಅಪವರ್ತನಗಳನ್ನು ತೆಗೆದು ಹೇಗಂತ ಗೊತ್ತಿದೆ ನಿಮಗೆ. So this is x minus 3 into x minus 1 divided by x into bracket x minus 1 into x minus 2. Now it is the time to eliminate x minus 1 and x minus 1. If you cancel x minus 1 and x minus 1, remains what? You see what remains? Limit x tends to 1. Limit x tends to 1. X minus 3 divided by x into bracket x minus 2 remains. X tends to 1. You put 1 here. So 1 minus 3, this is divided by 1 into bracket 1 minus 2. 1 into bracket 1 minus 2. So 1 minus 3 is minus 2 divided by 1 minus 2 is minus 1. So 1 into minus 1 is minus 1. So the final answer is 2. So this is what the solution to this example here. Is it clear for all or is there any doubt? Somewhat lengthy sum here. Actually ಸ್ವಲ್ಪ lengthy ಇದೆ sum ಇದು. ಅರ್ಥ ಆಯ್ತೋ ಮತ್ತೇನು ಕನ್ಫ್ಯೂಷನ್ ಆಯ್ತೋ? Okay. Now you see here. Next, one more example. Here, evaluate limit x tends to 1. X tends to 1. X raised to 15 minus 1 divided by x raised to 10 minus 1. Now you apply limit x tends to 1 to both numerator and denominator. Before that, you do one thing. See, standard limit, first one I would like to use. X raised to n minus a raised to n divided by x minus a. That form I would like to use here. It is somewhat tricky, please concentrate here. X raised to 15 minus 1 raised to 15 you can write. X raised to n minus a raised to n. Divided by x minus a I want. So x minus 1 I have taken extra. So x to the power 10 is there, minus 1 to the power 10 you write. And then you divide this by x minus 1. See, in the mode of simplification, this x minus 1 and this x minus 1. What we have divided for both numerator and denominator by x minus 1, that will be eliminated here. But you don't eliminate now. Purposely I have kept it as such here. So in the next step, you split the limit. So this is equal to what you can write? Limit x tends to 1. This is numerator, x raised to 15 minus 1 raised to 15. X raised to 15 minus 1 raised to 15 divided by x minus 1. One thing, divided by limit x tends to 1. X tends to 1. X raised to 10 minus 1 raised to 10. X raised to 10 minus 1 raised to 10 divided by x minus 1 here. So what happens? N a raised to n minus 1, you recall. See the pattern. What pattern you have studied? Limit x tends to a, x raised to n minus a raised to n divided by x minus a. This is equal to what you have studied? N a to the power n minus 1 you have studied. X tends to a, that a must be same. Here x tends to 1, 1 is there here. In place of n, 15 is there in the first case. In the denominator, in place of n, 10 is there here. Apply the formula n a to the power n minus 1. So how can we write the numerator here? 15 n, a is 1 to the power n minus 1, that is 15 minus 1. 15 minus 1 here. Similarly, how can you write it in the denominator? Can you tell me anybody? How do you write the denominator? Evaluate by standard limit. Hello. In place of n, 10 is there. N a to the power n minus 1. In place of n, 10. In place of a, 1. Come on. Anybody?
10. 1 into 10 minus 1. 10
minus 1. Very good. So 15 as it is. 1 to the power 14, which is 1 only. This is 10 into again 1. Then what? 5 3s are 5 2s are 3 by 2 is the answer. That's all. So this one I have done at the beginning. I don't want to repeat it. But by this method, x raised to n minus a raised to n method also you can follow for this substitution, that you can follow your NCERT book here. Refer ಮಾಡ್ರಿ book ನಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸರಿ. ಸೊ ಇಷ್ಟು ಲೆಕ್ಕಾಚಾರಗಳು ಇವತ್ತಿನ ವರ್ಗಕ್ಕೆ ಕ್ಲಾಸ್ಗೆ ಸಾಕು ಮಾಡೋಣ. ಸೊ ಉಳಿದಿದ್ದನ್ನು ನಾಳೆ ಮತ್ತೆ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ಗುಡ್ ನೈಟ್ ಎವ್ರಿಬಡಿ.